So let's start designing a lever for a specific job. Let's say we want a lever where one end of it moves 1 centimetre and the other end has got to move 4 times more, 4 centimetres. We need a ratio of 4:1. So one end of our lever from the pivot is 4 times compared to the other end. So if this was 1 centimetre, this would be 4. If this was 10 centimetres, this would be 40 centimetres. So a ratio is a way of comparing the length at one end of the lever with the length at the other, either side of the pivot. So if I've got a strip which is 5, 10, 15, 20, 25 centimetres long and divided up into 5 centimetre sections, we get 5 of them. 1, 2, 3, 4, 5. 5 fives are 25. So each part is the same, and what we need to do now is decide, well, how many parts have we got to divide it into either side of the pivot to get this 4:1. So this is an easy one. 1, 2, 3, 4 parts on one side, 1 part on the other one. Each of the parts is 5 centimetres long, but it would work the same if we had double the length of lever or half the length of lever, as long as we divided it up just like this into 5 equal parts. So where does the pivot go? Well, I haven't marked a middle position. It could go there, but that would just be a 1:1 pivot, a ratio of 1:1, just like a seesaw. It could be this one, but that's, hang on, 1, 2 parts there, 1, 2, 3 parts there. That's not 4:1. That would be 2:3. That's strange, isn't it? It's 2:3. We'll come back to that one later, perhaps. So we need the pivot point here, 1 compared to 1, 2, 3, 4. And that should get us our ratio of 4:1 when the lever starts to move. So let's go onto the pin board, pierce the hole where we're going to put the pivot. There it is. Now, just a practicality, this lever is so long it's sticking off the end of the grid, so it might be difficult to measure. So let's move it further back in. I'm also going to move it down a bit. We're free to move anywhere we want on the board, and I'm going to choose a point maybe there. Maybe, let's have a look. In from the edge there, I'm going to choose a point there. I'm going to always come back to it if we need to. So let's line it all up. There we are, straight along a line there. And we'll do the same as usual. We'll move it down a certain amount and see how much the other end moves up. So let's give it a try. Let's try what? Moving it down 3. 1, 2, 3 centimetres. Oops, just about there, 3 centimetres. Well, make a prediction. How far up did that end move? Now we've got to be careful where we count from, because we're not in the middle anymore. We've moved the pivot down to this line here. So it's this line. This is our sort of level reference line. So we've got to count all that way, haven't we? So if the ratio is 4:1, this is 4 times longer. That should have moved 4 times higher. But if this moved 1, 2, 3 centimetres, we've got to say 4 times 3 is 12. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sure enough, 12 centimetres. So our 4:1 ratio lever works just as we predicted it would, by having 4 times the length on this side of the lever and 1 times the unit that we've divided it into on this side. So this side is 4 times longer than that side, or this side is 1/4 of the length of that side. So that's a great way to do it as a ratio. And what we've used is a sort of notation with these numbers and dots. And that is how people express the ratio of a lever, 4 to 1. We could write it the other way. We could write it 1 to 4. And I suppose we could say, well, okay, you just reverse the lever round, and it does that. To get the lever to move 1 on this side up, I've got to move 4 times as much on that side. So that's an interesting proposition, and sometimes that's a very, very useful thing for us to do. So these ratios are useful because they tell us about how you can reverse a lever. Fabulous. Now here's the thing then. How would you make a lever with the ratio 2 to 3? Could this lever help us solve that problem as well and get an answer? So, how would you make a lever with a ratio of 2 to 3? See if you can have a go at that and try it out yourself on the board.